Hello and good evening. I hope you are all having a great Thursday. And I hope you're excited. This is the last day for this week's class. And apologies, I was late for some few minutes. So without wasting much time, we'll start today's class. We won't wait for the rest. They will join as we move on. So today we'll continue looking at the process of data cleaning. So far we have looked how we deal with outliers, and yesterday we looked at duplicates. So today we'll start looking at how we deal with the missing values. So today's class won't be any technical. We'll just cover some few not very technical stuff, more theoretical stuff. And I believe it will be a short session, not more than 30 minutes, I believe. So allow me to share my screen so that we begin. I believe when you are looking at outliers, I kept saying you can deal with them as you deal with missing values. So today we'll look at what do you mean by missing values, the different types of missing values that we have in Excel. Yeah, that's basically what we'll be looking at today. So what I mean by missing values are the situations where some cells within a data set might be empty, or in other cases, the entire row might be empty. So a missing value can be an entire row, an entire empty row, or just an empty cell or several cells within a data set. So they occur due to various reasons, maybe data entry errors when entering data into a database or an Excel workbook. You might miss out some entries leading to missing values. Sometimes if the data was collected by an equipment, the equipment might malfunction and skip some measurements or observations. Sometimes the nature of the data itself. So missing values within a data set are represented differently depending on the format of that specific data set. So dealing with these missing values or missing data is a common challenge in data analysis. And one approach that is key in addressing these challenges, understanding the mechanism behind the missingness itself. That's what we look at next when we'll be looking at the types of missing values and what causes the missingness itself. So we have four key types of missing values. We have the missing completely at random, missing at random, missing not at random, and systematic missing values. So we look at each of the four different types and how they differ from each other and how we address each one of them individually. Before we look at that, let's first understand what variables are. So in the context of data analysis and statistics, because in other fields, maybe in programming, variables are different thing, but it's not very different. So variables are a characteristic that take on different values, maybe such as height, age, temperature, test scores. In simpler terms, in the context of Excel, variables, you can view variables as the columns. Yeah, with the column heads or the titles being the variable names. So Basically, you have two types of variables, dependent and independent variables. I believe all of us are aware of that. So understanding the relationship between these variables, the dependent and independent, is crucial for analyzing data and drawing meaningful conclusions. So a dependent variable is the outcome or response variable in a study. So in other words, is the variable that you are trying to predict using the independent variable. Just as the names suggest, the independent variable is independent of any other variable, while the dependent variable is dependent on the independent variable. Hope that makes sense. For instance, in a study examining the effect of study hours on exam scores, the exam scores will be the dependent variable because they depend on the amount of time spent studying. On the other hand, an independent variable is the variable that is manipulated or controlled by the researcher. It is the variable that is used to predict or explain the outcome of the dependent variable. For instance, in the same study, the dependent variable in that case would be the number of hours spent in studying. Uh, with that, we can now seeing how variable dependence on a data set affect how we deal with missing values. So here are some two instances of how dependence between variables can influence how you use various approaches to handling missing values. So one of the techniques that are commonly used when dealing with missing values is imputation, including mean imputation, mode imputation, regression imputation, etc. So in cases where the dependent variable has missing values, it may be possible to impute these missing values with other related variables. For example, assume a data set containing information on student grades, which is the dependent variable in that case, and their study habits, which is the independent variable. The missing grades could be imputed based on the study habits of similar students. Also, when doing impact analysis, the presence of missing values in independent variables can impact the analysis results. So ignoring the values or improperly handling them can lead to biased estimates and incorrect conclusions. So in that case, you have to make sure you deal with the missing values appropriately to avoid biased outcomes or results. This is the example I have used to illustrate the difference between the dependent and independent variables. This is an example of a small data set with two variables and another column with the student ID. So we have the study hours and the independent variable and exam score as the dependent variable. In this case, you can see you have some missing values. In such a case, you can maybe you can impute the score, the exam score of student number 3 by observing the study hours of other students and maybe doing calculating the mean of students with similar study hours or closer study hours, and using that mean to impute the missing value or to replace the missing value. So this is just what I just explained. So as I just explained, just to repeat, if you want to deal with the missing exam score for the student with student ID 3, you could impute the value based on the average exam score of students who studied a similar number of hours. But we look more into how we perform in imputation and other imputation later next week. So as I said, we have 4 main types of missing values. The first one being missing completely at random. As the name suggests, it means that the missing values or the missing values within that the data set occurs completely at random. So in such a case, there may be no pattern as to why a column's data is missing. In this type, which is the short form is MCAR, which is missing completely at random, each data point has equal chance of being missing regardless of its value or other values or the values of other variables. So this randomness, actually perfect randomness, such that each cell or each data point has equal chance of being a missing value or missing a value, is what distinguishes this type from other types of missing data mechanisms. So the reason for missingness in this case is not in any way related to the data itself, the data that is missing, or any underlying pattern in the data. It could be due to random errors, for instance, maybe data entry mistakes or other unrelated factors. So in this case, there's no discernible pattern or trend in the missingness of the data. These missing values appear to be scattered throughout the data set without any systematic order. A good example, when collecting survey data, and some of the data might be missing because someone could not make it to an appointment, meaning their entry will be blank. Or another scenario where the administrator misplaces test results he is supposed to enter in a computer. If that happens, there'll be some missing values that were not entered. In that case, that will occur completely at random. So how do we deal with this type of missing data? So handling missing data under this assumption is relatively straightforward compared to other missing data mechanisms, because in most cases it's due to errors. In that case, you can safely remove the missing values from the data set unless the data set is very small, such that removing those missing values will make the sample size to be very small and distort the results. So since the missingness is random, the missing data can be safely removed or addressed using simple imputation methods without introducing bias into the analysis. So we can apply various approaches to deal with this type of missing data. The first approach that can be utilized is complete case analysis. In this case, observations with missing values are simply excluded from the analysis. So you entirely delete them or exclude them from the analysis. Although these are valid method, it can reduce the sample size significantly. So that's one of the disadvantages of using the complete case analysis, which involves completely excluding maybe the rows with missing data, completely excluding them from your analysis. You can also use mean or median imputation. This is where you replace the missing values with the mean or median of the other observed values. We look at how we do the imputation later next week. You can also apply a hot deck imputation. Someone wants to say something? Oh, I think maybe someone unmuted by mistake. So the other method we can use is the hot deck imputation, where missing values are imputed using values from similar cases in the data set. Like we had seen with the case of student scores and study hours. So this method we require to first identify similar cases based on other variables and can be more effective than mean imputation because you are imputing based on values from very similar observation with very similar characteristics. The other main type is missing at random. This is a type of missing data mechanism where the probability of data point being missing depends on the observed data, but not the unobserved or the missing data itself. In other words, whether a missing value is related to the values of other variables in the data set, but not with the missing value themselves. So the probability of a value missing or being missing data depends on the values of other variables that are observed in that data set. The missingness in this case is still considered random as it is influenced by the observed values, unlike the missing completely at random, which was not influenced by the other observed or unobserved values. It will just happen completely at random, maybe due to errors. So it is important to note that identifying this category, the MAR, missing at random, requires assumptions about the missing data mechanism, which may be challenging to verify. We'll see the example that follows. So moreover, if the missingness mechanism is completely assumed, it can lead to biased estimates and incorrect conclusions in the analysis. Let's consider the example below to better understand what missing at random means. Suppose you have a data set containing information about students, including about students' academic performance that includes their grades for different subjects, their socioeconomic status, and whether they receive additional tutoring. In this data set, missing grades occur because some students did not take a particular exam. However, in this case, let's assume, as I said, it as I had mentioned earlier, it is important to note that identifying MAR requires assumptions about the missing data mechanism. This is the assumption I'm talking about now. So let's assume in this case, analyses have shown that whether a student's grade is missing is related to their socioeconomic status. So specifically, let's assume that students from high economic backgrounds are more likely to have their grades recorded accurately compared to the students from lower socioeconomic backgrounds. So this difference in data recording is not related to the actual grade themselves, but rather the socioeconomic status of the students. So the probability of missingness, as I said in this category, is dependent on other observed or rather unobserved variables. Like in this case, the probability of the students' grades missing is dependent on their socioeconomic status. So in this scenario, the probability of a grade missing depends on the observed variable, which is the socioeconomic status, but not the unobserved variable, the missing grades themselves. So however, the missingness of grades is still considered random because it's not directly influenced by the missing grades themselves. So in this case, whether a student's grade is missing depends on their socioeconomic status, making it as a case of missing at random. I believe that example helped us understand better what you mean by missing at random. Let me think of another example. Uh, let's assume we are conducting maybe a medical study uh, to determine the relationship between things like exercise habits, age, and blood pressure or hypertension, in other words. So in that case, we'll collect data for three variables: the age, exercise habits, and blood pressure. Let's assume that upon completing collecting the data, during the analysis, we note that some of the blood pressure data is missing. So, however, we assume that our analysis have shown that the probability of blood pressure data being missing in this case is related to both the exercise habits and age, but not directly to the actual blood pressure values, which is the missing data. Let's particularly assume that in this case, older patients are less likely to reveal their blood pressure or to disclose information about their blood pressure readings, maybe because they are less active or do not visit a medical facility so often. And let's also assume that the patients who exercise less, people who exercise less, are also less likely to report their blood pressure in this case. So in such a scenario, the missingness of the blood pressure value can be explained by the age, or in other words, it's determined by the age and exercise habits, which are the observed variables, but it's not directly related to blood pressure itself, which is the unobserved variable. I hope that's now well understood with those two examples. Cool. So some of the common approaches that we can use when dealing with missing at random values, you can use mean or median imputation. I will look more into that, how we do it. We can also use regression imputation. We'll also look at that later. But just in brief, regression imputation is a specific type of imputation that involves using regression models to predict the values based on the other variables in the dataset. We use regression maybe to predict the value of a dependent variable using the independent variable and some error. Can't recall the exact formula, but that's basically what regression is used for. So you can also use multiple imputation, which is trying out multiple imputation methods and trying to find maybe a link between them or the one that better fits your data set. The other type of missing data or missing values is the missing not at random. As the name suggests, the missingness in this case is not at random. So this is a type of missing data mechanism where the probability of missing data is related to the unobserved data itself. For the others, it was very unrelated to the unobserved data. In other words, the missingness is not at random, and it is influenced by the value of the missing data. This can easily lead to biased results if not handled properly. So the missing data provides information about the variable being measured. For example, assume a survey about income, where high income individuals might be less likely to disclose their income, leading to maybe a higher proportion of missing values for that particular group. In this case, the missingness of the income data is directly related to the income data itself, or it's dependent to the income itself, or rather to the unobserved data or variable itself. So this scenario can lead to biased estimates if not well addressed. For instance, in the case of collecting income data, where high income individuals are less likely to disclose their income, any analysis based on the available income may underestimate the average income, so which will lead to misleading results. So dealing with this kind of missing data is more challenging compared to the other types of missing data, because the missingness mechanism needs to be modeled and accounted for in the analysis. So some of the approaches we can use to deal with this type of missing data, we can conduct a sensitivity analysis with the aim of assessing the impact of different assumptions about the missing data mechanism. This will help understand the robustness and the conclusions of to different missing data assumptions. Also, you can use model-based imputation. Here you can use statistical models to estimate the missing values based on the observed data. So this approach will require assumptions about the missing data mechanism and may involve complex modeling techniques. Also, you can use multiple imputation, and you can avoid it by improving data collection. So in a case, maybe you are involved in data collection, you can try make it as efficient or effective as possible to avoid any cases of missing data. The other type is the systematic missing values. So systematic missing values occur when the missingness of the data is not at random, just like missing not at random, but follows a pattern or is related to a specific characteristic or condition. In other words, this scenario occurs when the missingness of data follows a pattern or is related to specific characteristic or conditions within a given data set. So in this case, the missingness is predictable and can be associated with other variables within that data set. So this type of missing data can occur consistently across the data set or within specific subsets of the data. So the reason for the missingness in this case can be easily inferred or known from the data. So the missingness of data in this case can be predicted based on other variables in the data set. For example, in a survey, Missing values for income may be more likely among certain age groups or education levels. So systematic missing values are often associated with other variables in the data set. So, and this association can be used to infer the reasons for the missingness and to develop strategies for handling missing data. For instance, in a survey about lifestyle habits, older patients may be less likely to provide information about their social media usage compared to younger participants. The missingness of data, uh, in this case, social media usage is related to a specific characteristic, which is the age group within that data set. So how do we deal with systematic missing values? First, we can easily identify patterns. We can use exploratory data analysis techniques, which such as visualizations or summary statistics, to identify patterns of missingness in the data set, which can help understand the reasons for the missing values and guide the selection of the appropriate handling strategies. You can also use imputation, where the missingness is predictable and related to other variables. So, but it's good to take care to ensure you choose an imputation method that does not introduce bias into the analysis. You can also model the missingness or also use sensitivity analysis. And with that, I think we can call it a day. Allow me to end the class earlier today. Have another call in the next 18 minutes. So allow me to end it up there. So on Monday, we'll pick up from there. We'll complete looking at now how we address or deal with missing values. One final thing. I have talked about missing values, but I never touched on how we can detect them. There are several methods you can look into. But I think the simplest method you can use is using conditional formatting to highlight empty cells. You can use that, and if the data set is large, you can now then maybe filter the blanks. So maybe let's assume we have this data set and you want to check for missing values. You can use conditional formatting to highlight the cells containing missing values. So let me first to achieve that, we need to first highlight the entire data set, then insert condition of formatting. So you want to highlight or to mark any empty cell. So we just select is empty. That it will select all the empty cells within that data set. So it's now easier to see them. You can also maybe use filter to filter the data set, or to filter out the blanks. Filter and you can unselect everything else and only select the blanks. It will leave you with only with first console done. With that, you can be able now to filter out the blanks. Yeah, so for this column G, there's only one cell that is blank. You can do that for the other columns. If the data set is so large, maybe containing millions of entries, such that you cannot scroll down checking for the highlighted cells, So that's a very easy method you can use to detect missing values, some empty cells. So with that, unless there is any question, I think we can call it a day. Allow me to end the class earlier today. So we'll pick up from there on Monday. Perfect. So just hang on a minute as I organize for the quiz, the attendance form.